Well, over the past 11 weeks, I have introduced you to many techniques of CBM, be it vibration monitoring, be it wear debris analysis, be it motor current signature analysis, NDT techniques, and some of the results which I had discussed were actually from the research being carried out at our acoustics and condition monitoring laboratory at IIT Kharagpur, and we have many state of the art CBM facilities at IIT Kharagpur in our laboratory. And then sometimes I also as a consultant or go as an expert visit many industries wherein we carry a lot of equipment to do in situ balancing, in situ measurements, troubleshootings, etc. So, I thought I must also give you a pictorial guide of the facilities which we have at IIT Kharagpur, and also welcome all of you to come down visit our laboratories physically, because we also have visitors all over the world visiting us some time in the past, and they do that regularly from both the Americas, North America, South America, Europe, Asia. People visit us, Australia, spend some time with us, do research, do collaborative research, do experiments. I also go to other laboratories throughout the world and exchange ideas and collaborate, exchange students and so on. So, I thought I must let you know that what are the facilities available. We have few dedicated test setups, we have specialized equipment and a lot of software either at our laboratory or on campus wide, institute wide license software. These are some of the commercial softwares which we have, and we have access to do the modeling as and when required. While coming to this setup, we have an acoustical impedance tube where we can measure the materials properties. Initially, of course, some of these were actually developed by our own efforts, and then as time progressed, we also have procured some of the equipment to the international standards. We have the material transmission loss setup. We can measure the transmission loss of mufflers. We can measure the generated radiated noise, sound intensities, gearbox, NVH test rigs, material damping measurement, lot of data acquisition and signal processing systems, engine noise simulator, rotor test rig, machinery fault simulator, and chamber. Well, so some of these facilities are there. Well, coming specifically to some of the specialized equipment, some of them which you would have already seen. We have a DAT recorder, which is one of the oldest equipment in our lab, and it's close to about 15 years old. The OEM has stopped manufacturing them, but I still have them, and it's a very favorite equipment, so that I can take this recorder to the field and capture records and analyze them. So, in fact, I have recordings 15 years ago. I can play them to you. They will sound as if, and they will behave as if you are sitting next to the machine next to you. Many multiple channel analyzers, 8 channels, 4 channels, 2 channels, 7 channels, FFT analyzers are there. Of course, a lot of data acquisition systems and cards with high sampling rates. Even we have wireless systems wherein we can acquire wireless data acquisition. You must have seen the single point laser vibrometer. We also have couple of rotational laser vibrometers. For a lot of signal processing and underwater water acoustic studies, we have arbitrary waveform generator oscilloscopes. We also do studies in acoustic emission. We have a single channel acoustic emission transducer system. Again, for analysis, we have a lot of filter sets. A lot of these transducers, be it accelerometers or microphones, require power supplies which need to be portable, giving you the polarized voltage or the charge to voltage amplifiers. Okay. Encoders, we have high temperature accelerometers. These are charge type accelerometers. Then of course, associated amplifiers, power supplies, etc. we have the hydrophones for underwater acoustics, acoustic ping gun, few sound level meters, sound intensity probe. We have an omni sound source. We do a lot of human arm, hand arm, seat vibration measurements. We have systems for that, thermal imaging camera, 3-axis vibration exciter system, modal exciters, impact hammers, Hall effect current probes, phased array ultrasonic testing systems, and lot more. Okay. So, it is a full-fledged acoustics vibration condition monitoring lab, and I can proudly boast that perhaps this lab is the only lab in India amongst academic institutes which has all the equipment, okay, for CBM, for noise and vibration measurements, for signal processing, and so on. So, this is one view of the office space of the lab. We have about close to about 1,000 square feet of space, and this is the lab with some of the major equipment here. This is another view. Okay, we have of course to this lab we have IP enabled, so that you can cameras where you can access experiments also externally over the internet and so on. And you can see these yellow pelican cases. These are the cases which we have a lot of them, so that the equipment which are there, whenever I need to carry them to the field, I use these yellow boxes. Okay. And of course, I get priority checking and clearance in the airport with these yellow boxes. Okay. And then of course, a lot of sitting areas. Of course, this is the ground floor. In the top floor, we have the sitting areas where the students sit and they do all the numerical and the soft computing. We have a sound quality room. We have an NVH engine room. We have an underwater acoustic tank as well. So, this is a machinery fault simulator wherein I can do many faults in this, be it the shaft faults in terms of unbalance, in terms of misalignment, in terms of couplings, in terms of bearing faults, the motor faults. There are faults seated in the motor which could be replaced, gear faults, pulley faults, belt faults. We also have a pump which can be coupled to this, and then cavitation faults, impeller faults. So, this is a good setup wherein all such fault scenarios can be simulated, and then if you can see here, these are accelerometers which have been put. So, we can measure the vibration signature. Of course, you can also remove the control panel of the motor and get access to the current and measure the current from this machine. So, all sorts of tests can be done using such a system, and this is very favorite amongst the students to generate signal and so on, wherever they need to have nice signals in a controlled laboratory environment to develop signal processing algorithms. Of course, we also rely on a lot of field data, be it the railway locomotive data, be it a paper mill data, be it an underwater piling noise, be it a gearbox vibration in a cement plant. So, all this data is there, and that is why we carry that data recorder to the field and then capture the data. This you must have seen in some of the earlier lectures, that this is a view of the model testing being done on a portable air conditioning system of an Italian manufacturer, where they have identified us to do some noise reductions in this. So, we are doing a model testing here to find out the resonant frequencies. You can see this lab torso for sound quality analysis. You can get a view of the electromagnetic exciters with a slip table. So, I can excite it in 3 directions. Of course, we have a large panel TV where all the signals we can see. This is a model testing which is being done on a refrigerator, and you can see this is the electromagnetic exciter, and this end this is the impedance head, wherein I can simultaneously measure the driving point of RF by measuring the acceleration and the force at input to the system. And this is inclined because then I can give in vibration at 2 or 3 different directions. We have an infrared camera. This is a student using the infrared camera to measure the temperature. Okay, it's a handheld infrared camera with about, it can measure up to 700 degrees Celsius. All you have to be careful is how you set the emissivity, and the resolution is about 0.1 degrees Celsius. And this is a view of the thermal image of the rotor rig with an misalignment. You can see this black two discs. These are the heavy discs which are creating a load on the bearing, and you can see how the temperature of the bearings have increased because of the misalignment between the motor shaft and the shaft across the coupling. Okay. This is a video which was captured, so I thought I could share with you, and this video was captured by this infrared camera where we can also film such temperature profiles. This is myself holding this IR camera to measure the temperature of this engine. This is another 4-cylinder petrol engine which we have in the laboratory, which is instrumented with sensors inside the cylinder to measure the cylinder pressure, high temperature accelerometers to measure the cylinder vibrations. We have instrumented manifolds to measure the intake pressures, exhaust pressures. We have lambda sensors. So you can do a lot of diagnostics on this engine, both from a vibration point of view, from a sound quality point of view. We can see defects in this engine and do a lot of studies from the signals thus generated. This is the control panel of that same engine, where the student, and of course this engine is connected to an eddy current dynamometer where all the load tests can be done, the efficiency calculations could be done, and then you can see this Morse test where one of the engine cylinder is being misfired. This is the gearbox test rig I had mentioned when I was talking about the motor current signature analysis. This is the gearbox which you can see driven by a motor, and this is the control panel, and this gearbox is driving a generator, and then we have the resistance bank which is loading the motor, the gearbox, and then of course with the Hall effect sensors we can measure the current. This is the omni sound source, where we can generate a lot of sound, and this is a signal generator amplifier where we can generate pink noise, white noise. We can play recorded noise to simulate a lot of noises, because this helps to understand the building acoustics. We can measure reverberation time through such a system. These are some of the FFT analyzers. This is one FFT analyzer. This is another FFT analyzer, where we are doing signal analysis. Okay. And we have few more, which are dual channel FFT analyzers. And let me tell you, many people in many of the short courses I conduct, if somebody wants to be a free lance, CBM or NVH consultant or an expert, what is the minimum equipment which one should carry? I would first say, of course, a laptop connected with at least a dual channel portable USB based FFT analyzer. If you are low on budget, at least one accelerometer and one microphone. Maybe this as an input, maybe one tachometer. Okay. If you invest this, maybe less than 10 lakhs. Many of my colleagues who are watching this from the universities, students, researchers, who want to go into this field, this is from my experience. Within 10 lakhs of rupees, you can invest on this, and whatever you have gained or learned from me, you can become an independent engineer doing CBM, doing balancing, doing fault identification. Okay. And then of course, with time you can add maybe one Hall effect sensor to measure current, etc. Okay. So, I am sure with the advancement in electronics, miniaturization of transducers, the costs have come down and the technology is well understood today, and I do not see any reason why any engineer who has a little bent in becoming an entrepreneur cannot do this. It is quite possible, and I would be happy to see many such young engineers come up in our country who can do this and help the Indian industries. This is a measuring amplifier which can take in either the charge type or the isotron type accelerometer. This is an industrial vibration meter, and you can see the industrial accelerometer which is used. So, these are which are there. This is a hand arm vibration meter. Of course, we have the seat accelerometers. This is a probe microphone. It is a very expensive microphone. This diameter is about 1/8 of an inch, but this is used to measure the noise out of an engine exhaust. Okay. Such systems are there in place. I was mentioning about the rotational laser vibrometer. This requires a signal conditioner. Okay. This is the head of the rotational laser vibrometer. Okay. And then you can interface it to a laptop where you can calculate and so theta dot watches time. But the problem with this rotational laser vibrometer is for a fixed RLV to focus on a shaft which is rotating. Because of this separation distance, there is what is known as the standoff distance. So, one has to be careful about this standoff distance. Okay. Unlike the linear vibrometer, where laser vibrometer, where you can be measuring from over a large distance. And in fact, this is a linear laser vibrometer in the laboratory, wherein we are shooting the laser beam onto the outer edge of the bearing. Imagine in traditional vibration monitoring, I put an accelerometer on the housing, but if I have a laser beam, I can focus it on a very small point and measure the vibration, and this is what is being done in the present setup. Of course, we have a data recorder. Okay. This is a 16 channel data recorder, and this is my student working on the data analysis. Of course, you can see this colorful flags in my lab. These are the flags of the country I have visited, and I keep on trying to at least add one new country every year, and let's see what happens. Okay. And this is the signal which has been recorded, and in such data recorder, this is another lab, another engine which you have in the single cylinder engine. Of course, this engine, you can see a motor here. This could be fired off from the internet, provided you have prior permission. You can request me to give you prior permission with an allotted time slot. For some registration fees, I think you will be allowed to see the signals. This we are measuring the vibrations and all the parameters from this engine and dumped onto the computer, and through Team Viewer you have access to the data on measured from this engine, and then you can do all your experiments. Okay. So, even in the laboratory we have Team Viewer access for data, but this, because of safety issues, it is only to registered registered, not students as per in this class, so persons who are registered for this to access the data. Okay. We had an MHRD sponsored virtual lab experiment. So, this is a part of that virtual lab. So, we have such systems running, and then you can access to do any tests on automotive engine. Okay. So, this is also available at the internet, and of course, we have an IP camera, okay, where I can give you license or access, so that you can view some of the experiments while it is being conducted, view experiments. I believe whatever we teach or we study, it is nothing like doing it yourselves. Even holding an accelerometer or mounting an accelerometer on a machine is very rewarding. I mean, it sounds very easy that just go make a tap and put an accelerometer. But if you go to the real field, you may not have even access to this location. You may not have an access to a tap. There could be a lot of grease, a lot of sludge. Okay, so there are real issues. So I would recommend that whenever you get a chance, try out doing these experiments yourselves, trying to analyze signals, and then become a more versatile engineer. We do a lot of work for the Indian Navy, okay? And this is an underwater tank wherein we put in hydrophones, and so and of course acoustic pinger, and then this is the amplifier for the driving the acoustic pinger or the hydrophones, and hydrophones are usually charge type equipment. So a lot of underwater machinery monitoring. We have transducers for underwater vibration measurements, for underwater noise measurements, because people would like to know the condition of underwater machineries. So how do you measure the noise and vibration of them? So by hydrophone and underwater accelerometers. And we have a portable gensets. When I go to the field, many a times when we do experiments in the field where we do not have an AC source, sometimes I use this to power our equipment, etc. Of course, I would not recommend an AC source to power a lot of field equipment, because there should be proper AC isolated. DC source is much better. Otherwise, you can have the line supply frequency problem as a ground loop in all your measurements. So, wherever possible, try to use DC systems, okay, for measurement, for transducers, and it's a good practice to switch off your laptop and run it on the battery mode when you are taking signals. My students do a lot of signal processing algorithm development. This is an industrial PC, the signal analyzer for the laser vibrometers. This is an amplifier for the electromagnetic exciter. This is a filter wherein you can have a low pass, high pass, or a band pass setting. This is another amplifier for a sound source. This is an oscilloscope. This is a dual channel arbitrary waveform generator. So you can generate your own waveform and generate signals to drive any signal conditioning. We have a power source, and then of course a multimeter, a digital counter. So a lot of these encoders we need also to measure the frequency. Okay. So some of these signal data recorders which we have can take a multiple of inputs. For example, they will give you an ICP supply, they have a high sampling, input, they have a strain gauge, input module, they have a thermocouple, input module, and then they have an frequency counter. So, you can have all of these as plug-in modules to this signal data acquisition systems. And this is the view of the torso, and this is a sound intensity probe, and you can see the material testing tube here. Okay. We of course have the ultrasonic omniphase, the phase array system to here. We created a plate with artificial weld effect, so an ultrasonic scanning is being done. This is the slip table for the electromagnetic shaker. Okay. Of course, as I was telling you, I do a lot of external noise and vibration monitoring. This is somewhere in the Bombay High, where we are measuring an underwater piling noise. Okay. And you can see my favorite yellow suitcase. This is in a plant which we are measuring the blower noise. So, CBM is very interesting and wonderful experience. You get to do signal processing on your own, you understand the theory, you become field doctors. Okay. You go to the field, pick up data, troubleshoot, do a failure analysis, and you make some extra money as well. Okay. So, that keeps you going. Of course, I must introduce you to our research group. We have postdocs, PhD scholars, MTech students, BTech students, and then the students change every year, and we have a very vibrant young group who help in different activities. And of course, I must thank our sponsors over the years who have sponsored many of our projects, through which we are able to buy all this equipment, do research, do consulting, and help them. So, help the industry, help the classroom, help the students, and life is fun. Okay. Thank you. Of course, details you can see in our website. Okay. And of course, you can get hold of my book to learn the rest of the story. Thank you.